Hello everyone, my name is Bapi Ahmed and welcome back to another video of our DSA series. So guys, in this video, I'm going to discuss about something called drop constant. So this video will give you the entire idea like why this drop constant is important inside BigO and why we usually drop the constant inside BigO. So here a drop constant mean you can also tell it as remove constant or eliminate constant, okay, anything you can call. But most of the time in academic actually people uses this term actually called drop constant. So guys, drop constant is nothing but dropping constant means that we can easily eliminate constant values from the asymptotic analysis. So to make you understand this thing actually, what I will do, I will take one example and I will try to show you. So here if you see, I have taken the same function. I already used this function in my previous video. So this function actually prints some items actually. So this function takes one parameter called n. N is the number size. So let's say if you are giving 10 here, so it will print 0 to 9, okay, 0 to 9 value with the help of this for loop, okay. And I already showed you this function actually takes linear like runtime complexity, okay. During execution I already coded that part, okay, in my previous video, okay. So I have taken the same function here. So with the same function what I did here actually, inside that actually I have taken another for loop, okay. So this is the same for loop. As you can see, this for loop also prints the number, okay. This for loop also prints the number. And here I'm defining this is as I, and here I'm defining this like you can say variable as j, okay. This is the only difference. Now what I will do, first of all, let's try to code this function on our code editor and try to understand what is happening there. So guys, I'm inside my neural lab and I think you already saw this one, our linear runtime complexity, okay. So we use the same function. So what I will do, I will copy this code as it is, and here I'm going to create another file and I'm just going to name it as drop, okay, drop underscore constant dot py. Now here I think I can paste this code, and inside that I'm going to take another identical for loop, okay, the same for loop, but I will only define this variable as j. So range, and it will take this parameter called n, and it will print the value one by one, okay. So print j, fine. So this is the, let's say, function I have taken, and inside that I have taken another for loop. Now let's give one value here. So I'll take 10 here. Now if I execute this particular code, so let me execute. So Python something called drop constant, okay. Now see what will happen. See here, if you see guys, the first for loop, if you see, it is printing 0 to 9, okay. Here if you see, it is printing 0 to 9. Again it is coming here, again this for loop is executing, and again it is printing 0 to 9, okay. That means what is happening here, here two for loop is running, okay. So two for loop is running, and if you see the runtime of this function actually, so it is taking big O of n, okay, order of n. Also this for loop is taking big O of n, that means order of n, okay. Now what is happening here, so let me open my board. So guys, here is the screenshot of the function. So here actually this function is taking order of n time runtime complexity, and this is also taking order of n, okay. Now if you just like do the summation, let's say order of n plus order of n, so you will get something called order of, okay, big O of 2n, okay. So this is the complexity we'll get, this is the time complexity we'll get of this function, okay. Now here if you see, one constant value is there, okay. So this is the constant value, and here it is 2, okay. So 2 is coming as a constant value, okay. So here if you are having 2, or let's say 2 million, or let's say any kinds of number, okay, any kinds of constant number, what you can do actually, you can eliminate that particular constant here. So what you can write actually here, so you can write big O of n, okay. You can directly write big O of n, so you don't need to take this particular constant number, okay. So this is the idea of our drop constant, okay. Drop constant, or you can also tell it as remove constant, or you can also tell it as eliminate, okay, eliminate constant, okay. So this three term actually you can call, okay, and with the help of this idea actually we just try to drop any kinds of constant value, okay, from our BigO notation. So here what we're trying to do actually, so here we are just trying to making this term as simple as possible, okay, so that it will help us to understand our algorithm performance later on, okay. Now you are having some of the question in your mind like why we are removing this constant, okay, why it is required here, okay. So there are so many conditions you can consider, okay, for removing these kinds of constants. So I have listed down some of them, so let me show you. So guys, here if you see, it is very possible that BigO of n code is faster than BigO of 1, that means a constant code for a specific inputs. Okay, so this is one of the idea, okay, behind this dropping constant. Okay, now there is another condition actually, you can remember, different computers with different architecture have different constant factor. Okay, so if you don't know, actually we have two kinds of computer. We have faster computer and we have slower computer. Definitely if you are having good instance in your computer, so it is a faster computer, but if you are having poor you can say instance in your computer, so it is kinds of slower computer. Okay, so let's say you are having faster computer, so definitely this computer has like faster memory access. Okay, and if it is having faster memory access, so there is a lower constant factor. Definitely there is a lower constant factor, right? But if you are having slower computer, so definitely there is a slower memory access and you will be getting something called higher constant factor. Okay, so that is why whenever I'm defining this BigO notation, okay, like BigO of 2n, that means here I'm assigning one constant. Okay, here I'm assigning one constant. And what is happening actually, if you are executing this particular code to a faster computer, definitely I already told you there would be something called a faster memory access and lower constant factor. Okay, but if you are running the same code in a slower computer, you will get something called slower memory access and a higher constant factor. Okay, so that is why actually with this constant, actually my algorithm performance is varying. Okay, but if I can remove this constant here, okay, now if I execute this particular code in any kinds of computer, it can be faster computer or it can be slower computer, okay, my performance will remain same. Okay, so that is the idea of this dropping constant, okay, values in a BigO notation. Okay, whenever you are getting any kinds of like you can say constant value, okay, inside a BigO notation, or let's say inside a runtime complexity, you can drop that. Okay, and you can define as BigO of n. Okay, if you are getting any kinds of number, to it can be 2, it can be 2 million, it can be any kinds of number, you can define as BigO of n. And you can remember another condition, different algorithm with the same basics idea and computational complexity might have slightly different constant. Okay, so let's say here you have two kinds of you can see equation. So one equation is like a multiply by you can say inside bracket you are doing subtraction b minus c, and another is like a multiply by b subtraction of a multiply by c. Okay, so here you can assume multiplication takes more time than your subtraction. So here a multiply by bracket of b minus c, okay, will have lower constant, and definitely a multiply with b subtraction of a multiply by c will have the higher constant factor. Okay, so this is the complete idea of this drop constant. Okay, so these are the condition actually you can remember. Okay, why this drop constant actually it is important. Okay, whenever we are doing this asymptotic analysis. Okay, so here if you see guys, n can be any kinds of number, it can be also infinity. Okay, so that is why constant factor are not a really big deal. Okay, in this case, so that is why you should always focus on the actual runtime, okay, without any kinds of constant. Okay, and with the help of that you can do your asymptotic analysis. Okay, so yes guys, this is the complete idea of this drop constant. I hope you got the idea like why it is important, and in our next video we'll be discussing a new topic. Okay, with that, thank you so much guys for watching this video, and I will see you next time.